Howdy folks, I wanted to do a topic today, and this was something that's been on my mind for a long time because the last couple of years I've had some requests for it and had some more requests a couple of weeks ago, and then I think it was just the other day again, another request this week, and several people have mentioned it. The woodworking, I don't care if it's custom auto work or what it is, metal, even metal work, whatever, but a lot of stuff is involved with 3D printing now. And they're saying that by 2030, every household will probably have at least one 3D printer in the house. That's kind of optimistic, I think. I don't think we're going to get there, at least not yet, but I think it's heading that way. And if you're a woodworker even, you should probably have a 3D printer. The reason is stuff like this, where projects where you can have a 3D printer make something like that up for you, where we can, put these into a small desk or something and use these to help structurally, put something together, whether it be shelving or whatever. You can make brackets, that sort of thing. But you can just make so many different things. And look at this guy here, American Woodworker. This is an old magazine. I found this at a yard sale, so I had to have it because Norm was on the cover. Norm Abrams, yeah, from This Old House. Yeah. Anyways, so one of the things I want to do is 3D printing. But I'm going to start the very basics. The basic 101 of 3D printing. We're going to do what I like to call the hard way, or design something from scratch and get all the way up to where we print it today. So, hey, how about coming along and watching us? And I'm going to go ahead and we'll design something, and then we'll print it. And we'll see, what's involved. All right, hang around. Yeah, so there's a lot of different, right now I've got like 12 projects in here that I could 3D print something for that would help me with woodworking or some of my other tooling around here. But I wanted to do something basic and simple for you guys, so that you could, relate to it and get started with the idea of having a 3D printer around. So they solve problems. So let's take a look at a problem and then see how we're going to solve it. So here's a simple situation. We've got a vacuum line here for sawdust for any of my machines, and it's a certain size, and it does not fit this Beaver machine. So there are different sizes, but obviously one will not hook up or plug into the other. So we can 3D print an adapter that will allow us to hook this to that to vacuum sawdust off. So that's a good project. Wow, where do we start? Well, first we're going to have to measure this, and we're going to measure that hose. But I am going to do it in metric, and the reason for that is the software and everything just works so easily with metric that I had to give in. Yeah, I'm a half inch, 3/4 inch kind of guy, but it was like with metric, I can get accurate measurements and I can make really good modeling off 3D printers for making, in this case, an adapter. And I highly recommend just bite the bullet, get the metric. You'll need some metric measurements, such as a caliper like this that will allow you to use it in metric. Really, like I said, I can't say enough about it because the software works better with the metric, and when you get into the slicer and the other stuff with the 3D printer, the metric just seems to flow better, period. Blank sheet of paper and a pencil, because we're going to make a bunch of notes and sketch this thing up as to what adapter, what it's going to look like, how big is it going to be, and then I'll show you how we're going to sketch all that up on something, and then we're going to put it into a slicer. The slicer will then transmit it to a G-code. The G-code will be going into the 3D printer to actually make the part. Oh, and we're going to run with whatever color plastic I have left laying around here right now. Yeah, so it might be a weird color. So here's the paper, and I've sketched out and took the measurements. Now this is all in millimeters. Like I said, I like to work with the metric when I'm doing this stuff. And I don't even round the numbers up. I actually take the actual numbers and write them down. Sometimes with something like 62.69, I might round that off to, 62, 0.70 or 75, something like that, just to make it a little oversized so it'll fit, the sleeve will fit even better up here on this this pipe. And then the other pipe, or the vacuum line coming in, this is the vac line here. The only thing I need is the outside diameter. I don't care about the inside as to what it is, because the outside is what our pipe or sleeve is going to be working with. So it's 57.76 millimeter again. So what I decided was, for length, I'm going to go with 60 millimeters long, which will be the adapter to have, put these two together. And the outside of this casing, the overall outside, I'm going to make it 67. And how I determined that was I want about a 4mm wall or thickness to the pipe. So I added the 4 here and also rounded up from here, ended up at 67. Yeah, 67mm. So the only thing I got to do is I got to drop a pipe, the 67mm on the outside, and then on the inside I'm going to draw these 2 different sizes, which will be the 57.76 and the where are we here? 62.69. And I will, like I said, I'll probably make this just a little bit bigger and probably make that just a little bit bigger so she sort of, just sort of slides together, sort of sloppy a little bit. You will find with 3D printing that these numbers can be very accurately duplicated on a 3D machine, and at times it will absolutely amaze you how close to these numbers your 3D printer will actually make these parts. And that's why it's kind of important to stick with these numbers. So now, let's go to the software and let's enter this information and see if we can make this part. All right, this is the Fusion 360 page, and this is the very beginning. When we first open it, this is what we're going to be seeing. Now, Fusion 360 is a CAD program, and it's free if you make less than $1,000 a year off of 3D printing. So, yeah, you kind of, if you make more than that, you have to buy the subscription, and it's pretty pricey because this one here is called the Beast, and there's a reason for it. It's very hard to learn. It's got a steep learning curve, but it's probably the most powerful one out there. I think it is truly, the very best. I really like it, but I can't afford it. I have to admit that. Now I'm going to go up here. I'm going to use a pencil or something here just so you can see. Up here in the top, I'm going to click on top, and now we're going to do update right now. But now we have a very, very vague grid here, which I don't like. I wish the grid was a little stronger on the graph paper, whatever here. But we're going to go up to the corner here, which is over here, to create. And we're going to click on create and come down to create a sketch. Then we're going to click in the center here. And you'll see all the new information is all changed up the top here now. And then we're going to grab the circle, because obviously that's what we're going to make. Now, the very first thing we can do is we can come out this way. And we've already determined that the pipe size from our notes was going to be 67. So I'm just going to punch in the keyboard on the computer here, 67, and hit the enter. Boom, we've got it. Now, the length of this, I'm going to extrude it, is going to be 60mm. And again, so I typed in the command 60mm, and I'm now going to hit the return button. And now we have this big solid hunk of whatever it is. Yeah, and let's go back to the top. Now from the center, I'm going to right click and pick hole, because that's what we're going to want. Now the hole size and the depth, this is where we have to, over here on the right hand side, this is all the information about the hole. Now we don't want the hole any more or less than a certain depth. So because we know this is 60, we can split that in 30. So we could say we want to, let's make it for just depth, we're going to say 20, we're going to say the hole is going to be 25mm deep. So less than half the pipe at this end. We're also going to do a hole on the other end too. But right now, that's what we want. And then we're not going to worry about this at all, because this is not going to be that type of hole. Well, also the type of hole we have picked is a simple hole. You can pick counter bore and countersink, all kinds of other fancy ones. But that's the hole size we're going to be picking for today, right now. And hopefully this is in the center. That's another problem I do have with Fusion 360. Like I say, it's very difficult to learn. This should be, hopefully it's in the center. I believe it is. Now the actual size of the hole from one end, we decided was, and from our notes, okay, I had to stop for a second there and fix a couple of things here. This is wrong, so we're going to back that out. And like I said, I think we'll go up to, let's go to 70 at least. Just make that just a little bit sloppier hole. You could even go 7.5, because you are talking part of a 1mm. Just thinking like in terms of like an eighth of an inch, and you're playing around with it, so it's pretty small. The other thing too is the hole has to meet up in the center. So we're going to go the whole, I'm going to change these numbers to 30. Yeah, I think we'll change to 30. And that'll be 30mm now for depth. That's half the pipe. And the hole size will be 62 point, how did I get 7.7 here? Excuse me, 7.5. 5. And we'll hit the enter. And now you can see that there's a hole there, but it doesn't go all the way through, which it shouldn't. Now we're going to come up here to the corner, and I'm going to flip it. I'm going to flip the whole pipe upside down. And now we're going to make a hole again. Whoops. From this side, which of course has to line up in the center, which it just did. Now this hole, the depth is going to be the same, but this time we're going to be changing this so that it fits the other end of that pipe. And this one we recorded 57.76. So we're going to back that down to 57 point, and I said 76. Now let's go up a little bit, and it's in red. Don't mind the red thing. It's just me. I just hit the wrong number here, but here we go. Okay, and I'm going to round this up to 80. So I'm going to add a little bit more to the hole size. Okay, and there we go. And now we can go to the home position, and you can see the different. Oh, sorry, I just did that wrong. I grab the hand here on the software, and I can pull this thing around. Also, I can do what they call orbit. And with orbit, I can take a look at the part and actually see it visually as to what's going on. Now, what we're going to do at this point, I'm going to back away from it just a little bit because this makes it easier. And we're all done with the Fusion 360. So now I'm going to left click my mouse, and I'm going to pull it all over the part like that. Now I'm going to go up to the file here, and I'm going to come down to 3D print. And it's going to ask me some information. Now we're going to be using the QD machine, the Cheaty machine. So we're just going to push OK. And this is going to go straight over to Cheaty and set up a job for us on the, in this case, it's the Smart 3, whatever. And of course they want to, we'll get back to you on that, Cheaty. There you go. Now, we don't want 15, we want 20% infill. So it's a fairly strong part. Color-wise, I don't think anybody should care. It's just a PLA material is all we're going to be using. So now we're going to come down to where it says, bottom here, where it says slice now, and we'll hit that. And it's going to slice it. And it's going to tell me it's 54 minutes to make the part and export G-code. Now, I'll need the actual USB, the little memory stick in the computer so I can save the G-code to that, because obviously we're not going to save this part or anything. So I'll have to go get it off the machine. I'll plug it in. We'll be right back. Okay, so I'm going to put the USB stick in the computer now from the Cheaty machine, and it should come up here actually and show a. There you go. Now it shows a little export to a USB stick. So we're going to come down here and we're going to export that file, and it's a body. So we're going to change the title to let's call it the VAC adapter. And you really need to do that just so you can find it when you go to punch it up on the machine. So we're going to save it, and it has now saved it to the USB stick. So now we can close all this out. Now when I close out Cheaty, when I quit, it's going to ask me to save the file and say discard, forget it. I know, just discard the whole thing, don't care. And we're back to Fusion 360 where we originally designed the part. So now, let's see, we're going to cancel. We're going to get out of Fusion 360. And again, we're going to just, don't save, we're going to just discard. And we'll go out to the machine and we'll start the process at that end. Okay, so now that file is now loaded on this little USB stick, which I have to put in the Cheaty. And that's another issue that, yeah, there we go, it's plugged in. So now I've got the files in the machine. The machine is loaded, ready to go. And we're going to go look for the file. And it was VAC adapter, so it could be in here someplace. We'll have to look for it and see if we can find it. It's one of the reasons why I insist on making sure you write the stuff down, because there it is, VAC adapter. It's a new file. And we're going to pick that. Now it should show us, well, maybe it won't. It should show us a preview look, but it doesn't show it. So that's fine. And we'll tell it to go ahead and run. And I'm going to close that up. Now, it's going to start running and make that pipe that we just designed. And so it's going to take about an hour. So I'm going to cut away and we'll come back when it's finished printing it, because it's, like I say, it's going to take about an hour to print that thing. So when we come back, yeah. there it goes. We're all done. All right, so we now have the part made that we drew, and it's going to be a little sticky to get it out of there right now because it's still a little hot. So Cheaty gives us this nice mechanical plate here that's magnetic that just pop it off like that, and we can close her up. Confirmed. Okay, yes. And we're good. Now, there's the part. You can see the ridge in there for the two different sizes. Let's take it to the shop and see how it fits. Yeah, so there it is, the part that we drew up. Now, the smaller end, which was for the vacuum, and it's, boy, it's a nice, there we go, nice tight fit, snug, very snug, but that's fine, you know, for what we're doing. And now for the V-bore, same thing. It's a nice tight, yeah, there we go, nice tight fit, but there you go. Now we have an adapter so we can hook up our vac to system to pull the sawdust out of there. But the whole idea today was to show you the basics of, you know, 3D printing and how you can make some incredible things. This is a no-brainer, but you know, there's some really great things you can do. Also in that software, I could actually put a little fillet on each end of this to make it easier for the pipes to slide in, slide out, that kind of thing. There's just so much you can do with the software itself. Now, let's go over to the bench and over here and we'll talk about it. Well, I hope you got something out of that. This is one other little item I forgot to mention. When this first comes off the 3D printer, it's still it's pretty hot, it's pretty warm. And so the size is a little bit off until it cools. Once it cools, you will have hopefully the correct size that you should have. So this fits on better now than it first did when you saw me, because it was still hot off the press, as they say. So yeah, once it cools, it'll take on its natural size or get close to what you called for in the print. And right now it'll just fit just that much better now that it's nice and cool. And it's a, you know, cool little part, but very useful. Just a very, like I said, very basic situation. The first thing about 3D printing is if you want to do your own designs and then make that stuff, that design software or that drafting or CAD software you like, Fusion 360 is just, I just find it's the best one out there. I have not really liked anybody else's. The biggest problem is the subscription plans. Shaper 3D, for example, I really like that one, but when they hit me up for the subscription plan, it was, you know, it was like, oh man, that's way too much money. I can't afford that kind of dough. And definitely can't afford 360 for that matter. But they're all, you know, hitting that subscription. Now, last year was the first time I saw it. There's a new one out called Plasticity. Plasticity. Anyways, I'll print it here on, you can see how it's spelled. Yeah, Plasticity. I guess that's how it's pronounced. And it's got a whole different base to it. You buy the software. So there's no subscription fee. You pay a one-time fee of, I think it's $149, and you own the software, which means you can reuse the software over and over again, you know, forever. Fusion 360, a lot of them are cloud-based where they're controlled from the server. If your subscription fails that month, boom, you no longer can, you know, draft or draw something up. Bummer, dude. Now there is FreeCAD, but I've tried FreeCAD over and over and over again until the blood comes out of my ears. And I can't stand it. I absolutely just cannot stand that silly program. It doesn't do anything for me. There was a number of them. I tried SolidWorks was another one I tried. There's also Shaper 3D. Shaper 3D I really liked, but the subscription was just, whoa, you know, again, you know, too high per month. I think if you're going to do 3D CAD drawing for, you know, people like myself who do 3D printing, the CAD software, if it was like, you know, $8.99 a month or something, that would be fine, but it's not, you know. So Plasticity has come out with this base, and it has a hook. Okay, yeah, it's free software for 30 days, so you get to try it for 30 days, see if you're even interested in it or if you like it. And at the $149, you buy the package, and that's it. Now you probably get some updates, but you'll get updates for about I think it's a 1 year period, they said, and then at the end of the 1 year. After that, you'll have to pay to get into the next version, because there'll be an update version. Like right now, I think it's at 1.4. So if it goes to 1.5 or 6 or whatever they do, at that point, they'll ask you for some money, you know, and you can own the new version. You don't have to buy into it. You can stay with what you have. If you can get by on what you're doing and what you're working with, then it's a great program. If you need those updates, then yeah, it's going to cost you a little more. But I still like the idea that you pay a one-time fee. That baby's yours and it's done. It's not like Adobe or something where every month it's a subscription fee. I am getting so tired of subscription fees, so I like to either go free or software that I can just buy and be done with it. And that's really the biggest part about basic from design to 3D printing. You're going to need CAD software, and you're also going to have to learn it. And learning Fusion 360, everybody says it's very difficult, very hard. Heck, if I can learn it, anybody can learn it. That's what I'm thinking. But also the plasticity, I tried it, and it was clunky for me because I kept trying to use the shortcuts that I'm aware of with 360. So it was a little bit, hard. You're sort of jumping from one type of software to software that works differently. And once you learn it, I'm sure you'd be pretty comfortable with it. It looked very powerful. It had a lot of promise. There was a couple of shortcomings. Fusion 360, for example, I can cut a hole and I can thread the hole, and I can actually choose what, Acme 20 thread, quarter-inch thread, whatever. I can pick out whatever I want for hole size or threading. And I found their whole thing was really clunky. Didn't like it, but like I said, over time with the updates and things, I'm sure they'll get a better hole punch system in there. They had some terrific. There was one thing in there that I saw, and I had to take a good harder look at it, but it looked like it can do something that 360 cannot do. And it was like, whoa, wait a minute, that's kind of interesting. You got my attention. So I'm going to be trying that one over the next 30-day period and sketching with it and just see how it works with me. And if I can get really comfortable with it, I will probably have to break down, get the towel out, do some tears and cry, and then Mama will say, okay, go ahead and spend the $149 for the software so you can own it. Yeah. But hopefully this helped. Piece of paper, pencil, digital calipers. You have a problem, measure it up, figure out what you have to do, and then go draw it. There was one other thing I missed on, and I should have probably touched on it, was because this is two different sizes, this is what we would, in some cases, could be an overhang. But because we printed it this way with the thicker part on the bottom and the thinner part on top, there is no overhang. If I had decided to print this upside down, this would now become what we call in the business an overhang, and it's a problem. It needs to be supported. That's something you have to look for out. You have to look out for. Once you do your drawing, a lot of times you'll need support for your drawing or something. We have a product here that it took me a while to figure out how to do it. We actually end up printing it upside down with supports in order to get a better finish for the product for the client. So it's just something that, some steps we had to go through, but I was really happy with it. Hey, thank you so much for watching Coffee and Tools. Please like, share, subscribe, ring the notice bell. We're giving tools away. I think we're giving away a setup block set from Vivor right now. We really need to get that done. So next week we have got to give that away so we can get to this next tool that we want to give away to a viewer like yourself. So hey, fabulous. I'm out of here. Yeah, over and out.